Hello and welcome to this session about creating a Java and Spring Boot application using an AI skill and GitHub Copilot. I'm Julien Dubois, I'm a Java champion working for Microsoft, and I'm well known in the Java community for having created Gipster, which is a Java and Spring Boot code generator, but that's using something deterministic. We coded it, and it's generating something based on the options that you choose. Today, we're going to do something similar, but using AI. So it might be a bit more creative at first, but then we'll see all the benefits in the second part of this session when we will update our application and where AI will be really good at modifying code when Gipster couldn't basically do that at all. So let's get started. Let's have a look at this AI skill. So it's here on GitHub. It's called Dr JSkill for Dr JavaSkill, of course. We've got a nice logo. And if you go to that website, you can have a good description on what Dr JSkill is doing, but we're going to use it straight away because the best way to learn is just to use, of course. So I'm going to run here GitHub Copilot. This skill is normally already installed, so let's have a look at my skills list. Yeah, here it is. Dr JSkill is already installed. This skill is going to use some files and some scripts, so a good practice usually is to add the directory of that skill inside GitHub Copilot, so it doesn't ask you for permissions to run everything here. So I'm adding it right now. And then I can start to use it. So it takes some time to generate the application. So I'm going to start it quickly. And then while it generates the application, we will have a look at what is being generated, how it works, and why I'm doing it that way. So in order to run it, there are different ways. The easiest way is to just call Dr JSkill. And I'm going now to type the specifications of my application. The technical specifications are basically managed by Dr JSkill. It's going to be Spring Boot, Java, and everything. So what I'm going to type is some end user specification. So I want to create a to-do list application. I want to add, edit, delete to-dos. I want to store them in a database, of course. And as I suck for the front-end part, I'm going to ask it, create a very nice and fancy UI. So here I want my LLM to be a bit more creative for the UI part. I'm hitting enter. It's going to think quite a lot to generate everything. So first of all, it's going to create a plan. Then it's going to execute that plan. It might ask me a few questions because I wasn't precise enough for some parts. Typically, I didn't tell which kind of front end I want. So yeah, that's the first question I'm having. Which front end do you want? So it's recommending React, Vue.js, otherwise Angular or vanilla JavaScript or something else where I can type whatever I want. I'm going to use Vue.js. That's the default normally with Dr JSkill. Here is so that I wanted something fancy and nice. So it went a bit creative and so maybe React would be better, but I would stick with Vue.js because it's my favorite one. So I'm hitting enter. So as you can see here, I didn't pre-code the questions. It's mostly the AI using the skill that understands what I want and which is asking me questions when it needs more direction. And otherwise, it's just going to execute the AI skill by itself. It's doing the plan. It's going to generate stuff. Let's have a look really at what that skill does. So if we go here, we need to go to that skill.md file. That's a real file that is being used by Dr JSkill. That main file is pretty small. So we've got some generic directions. So here is the project structure that we want, for example. Here are the best practices that we want, but it's not too big. The issue sometimes with skills is that they are too big and then they pollute the context of the LLM and the LLM becomes less performant. Here what I want is to have something which is of course very efficient. So I have splitted my best practices into different guides. If you have a look here, we've got guides, for example, for logging. So when it needs to add some logging, it will look at this specific guide. Those are basically lazy loaded by the AI, depending on what it does. Some of those best practices are not being used at all. For example, I'm not going to use security today. So the security guide will not be loaded. I'm going to use a database, so the database will be loaded. Depending on what I'm asking my GitHub Copilot to do, it will load one or several guides. You might have seen them here being loaded in that window. Here they are. So it loaded Vue.js, but not Angular or React, for example. It has started to generate my application. In order to do so, it used start.spring.io behind the scenes. So there's a script that runs. It downloads the latest start.spring.io application from the website, and it's going to update it and enhance it with, well, all those configurations that I've told that I wanted. It's going to create a backend and a frontend. So the backend will be with Spring Boot and the database, which is PostgreSQL, and the frontend will be with Vue.js, because that's what I have asked it to do. It takes some time to generate the application for different reasons. So the obvious one is that we use an LLM, so the LLM takes time to sync and generate stuff. There are two ways to make it faster. So first of all, here I'm using Cloud Opus 4.6, which is a very high quality LLM. So that takes more time, but in exchange, I've got a better output. Here, as I'm generating an application, I'd rather have something slow, but of high quality than the opposite. So that's why I've chosen it. The other option that you can use to make it faster is to use fleet mode. So here you can type /fleet and basically ask the same command that I just did. And this is going to create a fleet of agents. So basically it's going to generate the structure of the application the same way, but then it's going to see, oh, I want to create a backend, I want to create a frontend, I want some Docker configuration files. All of those can be done in parallel. So it will create different agents that work in parallel. In the end, of course, it will work faster because I will call my LLM in parallel and not sequentially like here. I'm just not doing it for this demo because it's harder to explain what's going on if it's in parallel instead of sequential. So here we're doing the sequential way, but again, you want to go faster, you can try the fleet mode. It's really funny to see all those agents working together and acting at the same moment to generate your application faster. Last thing that makes this generation a little bit slow is that I've got some validation at the end. Let me just go down. Where is the validation? Validation, here it is. What we're telling GitHub Copilot here is that when everything is generated, you need to run Maven install, Maven test, Maven verify, and run the front end. The goal here is to check if there are any errors. If there is any issue, well, we're still in the loop of creating the application with GitHub Copilot, so it will understand the errors and it will try to fix them. So for something simple like this, we probably won't have much errors, but if you do something more complicated, you might get some errors and it will fix them in a loop until it succeeds. That allows you to have much less worries, like you're just waiting for GitHub Copilot to finish, and you will have a working application with, typically here with Spring Boot, which compiles, which is tested and verified using integration tests. So you're pretty sure that it's a good working application in the end. So my application is still being generated. So it created the backend with the Spring Boot. We can see here the Java code. Created the frontend here with Vue.js. Now it's building everything. I can start to have a look at what's being built. So let me open up that application with IntelliJ to have a look at what has been generated. So we can see that IntelliJ immediately saw we've got a dev container configuration. So one of those nice things that we generate is dev containers. So dev containers allows you to reopen your project inside the Docker container where you can guarantee that people will use Java and Node.js, for example. So that's very good when you want to share your application with other people. In my case, I don't really need it because my laptop is well configured, of course, but that's very nice. Then we can see that it generated here a front end with Vue.js. So if I go typically here to services, we've got a to-do service. You remember we wanted to create a to-do list so we can add, edit, and delete to-dos. Well, that's the front-end part of it. So that's my Vue.js frontend, if I have a look at my Java code, main Java, typically if we go to the controllers, we have a to-do controller, and same thing, the to-do controller has got REST endpoints to create, edit, or delete to-dos. We see here that our AI skill generated both the front end and the back end in a consistent way, and everything seems to be able to work correctly. Let's have a look at the generation. Everything seems to be finished. It says we did a backend, we did the front end, we tested. Everything should be working. So let's run everything. So easiest way to run it is to run the main class here. So IntelliJ automatically saw it. Otherwise, you run Maven Spring Boot run, like what is being proposed here by GitHub Copilot. Let's run it. This should start automatically in my Docker database. Let me just open up Docker desktop here. So you can see the database being loaded. Here it is. So we've got PostgreSQL, which is automatically configured, and we're going to use it immediately. So my backend is running. Now let's have a look at the front end. I'm going to have a look here, show npm scripts, run dev, and that's going to run my front end. Here it is. And the front end should connect to the backend and everything should work. So let's have a look at the generated application. What needs to be done? Let's put test. Yeah, seems to work. Test again. Okay, so my to-do list application seems to be working. I can close some to-dos, create more to-dos. I can delete some to-dos. Yeah, everything works. That's pretty cool. I've got a nice and fancy UI as I asked. So I generated a nice Spring Boot and Java application using my AI skill with Dr JSkill. Now let's have a look at where AI really shines. I'm going to improve that application. The first thing is that I don't like the look of that application. I'm going first to do something quite simple. I'm going to modify the UI. So I don't like how it looks. So I'm going to modify it. I'm going to say, I don't like the UI. Make it pink with unicorns. I want something very different. So just putting that very simple prompt. Here, GitHub Copilot has got the context of our AI skill and of our application. Basically, it will know what to do. It's going to update my application automatically. As I'm using Vue.js, we're going to have auto-reload of everything. So I'm not touching anything. I'm just letting GitHub Copilot and CloudOpus sync, generate some new files, and we're going to have a new UI being automatically loaded here. So let me put them next to each other so we see better what's happening. And here it is. So it generated some new Vue.js configuration. You can see the unicorn and the rainbows. It's wonderful. And everything is pink with unicorns. So I can tell it, ooh, wonderful. Oh, it's still, it's still building some stuff. Basically, it's rebuilding everything to see if everything is fine when we can already see that it's all okay. That's great. Wonderful. So I only modified my front-end files. That looks easy. I mean, honestly, that's not too bad. Now we're going to do something even more complicated. I want to modify the backend, the database, and the front-end. So something a lot more complex. And let's have a look if it can also handle such a complex task. So now I want to assign those to-dos to users. I want 3 users in my database. So you've got Julien, me, Alice, and Bob. What am I asking here for real? I wanted to update the database, so we need to update that PostgreSQL database running in Docker. I need to update the Spring Boot backend because we need a new repository. We need some new controller. And then we need to update also the front-end part because we want to be able to assign those to-dos. Something which is fairly complex. As we can see, it made a plan. It's now executing the plan already. It's creating the backend files first, the controller. We can see it's creating a data initializer class. Let's have a look at that class because that one looks really interesting. Here it is. So that class indeed creates 3 new users, Julien, Alice, Bob. So it created that new class to insert that data as I've asked it to do. Pretty cool. And it's also generating some new tests. So it's going to test that what was generated is correct. Well, we can guess the test will be okay. And after that, now it's creating the front end. So it's also going to update the front end. I'm still basically not doing anything for one very good reason. So as we have seen earlier, the front end uploads, reloads automatically with Vue.js. It's the same thing, in fact, with the front end. We're using the dev mode from Spring Boot. So Spring Boot normally will see that it has got some new code. You can see it here. It restarted. It is restarting, updating the database. And as the front end is also restarting, well, basically I don't do anything. The database, the backend, and the front end are all automatically restarted without me doing anything. We can already see here the front end. This is unassigned. We've got Julien, Alice, Bob. We know this is going from the backend, so this is already good. So I'm going to type some random text, assign it to myself, and add this to me. Oh, 500. I'm going to let me refresh. Oh, the backend is probably restarting right now because it was finishing. It's running the test. It's finishing. Let's give it a bit more time. Add it. Yeah, now it's working. It finished running the test, so my backend was started correctly. So wonderful. I can assign more stuff to, let's say, to that other person. I can have a look. Assign it to me again. Save. Everything works. So I can now assign my to-dos to different people. So we modified the database, the backend, and the front end, which is pretty cool. Now that we have seen how to generate the app and how to modify it, we're going to run it in production. And for that, we're going to have a look at one last configuration. It's the Docker configuration. So we've got a few Docker files. That first one is just for development. That's how our production database here is being started automatically when I start my Spring Boot application. I'm going to stop all of this. And I have two choices. Basically, I can either generate an application here using Java, so I can run Docker Compose here. So I will have my application coded, of course, with Spring Boot, deployed inside the GVM and connecting to the PostgreSQL database. Let's let it run, and we're going to see it happening here. So here the build is pretty fast. We're mostly waiting for Maven dependencies to get downloaded, and then compiling and running. It's pretty fast with Java. Just running the application will take something like 1 second because Spring Boot is a little bit slow. I mean, 1 second is okay, but we can have a look at the startup time and the memory that is being used by Spring Boot running inside the GVM. Yeah, everything is done. It's now packaging the app and packaging the front end. You can see here, run npm install. And once it's all done, we'll see everything running here inside Docker. Yeah, here is our application coming up. Let's have a look. Yeah, here it is. And the application is up and running. We can go here to 8080. Oh, so it's not running yet. Come on. Yeah, here it is. My application is running inside the GVM. So we're quite happy. And it's taking, that looks a little bit slow. Hang on, the memory usage, sorry, is 266 megabytes. So we're using some memory. It's not crazy big, but that's the GVM. So it started up quite fast, but it's using a bit of memory. We can have a look maybe here. Do we have some? We don't have much logs. Yeah, it took 21. Yeah, it took 3 or 4 seconds to start up. But it also created the database, so it's not only Spring Boot which took time. Okay, wonderful. Now let's kill this, and let's try again with this time GraalVM. So there's a lot of work that went into that AI skill here to be able to be compatible with GraalVM. So GraalVM is going to basically do the same thing as a GVM, but the build will take longer because it needs to compile everything as a native image. So probably we're going to pause that video to wait until that build finishes. But once this is done, startup time will be much faster and memory usage will be much lower. So we had 266 megs of RAM and it took a few seconds to start up. Let's wait until this build finishes and then we'll have a look at what it does with GraalVM native build. I'm going to pause this and I will catch you up once it is all finished. So my build is finishing right now. Let's just have a look. It took about 200 seconds to generate the native image. So that's what took most of the time, a bit more than 3 minutes. And now my app is already running because that's super fast with GraalVM. So let's go back to Docker. We can see it here. That's my native image. It started like in 1 millisecond. Yeah, couldn't even see anything. It was 54, yeah. So it took some time because of the database, but once the database was created, everything was super fast, created the default user, and everything was created. Let's have a look at the memory usage because that's the most interesting thing. We were at 266 megabytes with the GVM. This time we are with 76 megabytes with the native image. So a big decrease in the memory usage. The good thing with that kind of application is that you can deploy them easily to a cloud provider like Azure. There's our skill, of course, supports Azure because I work for Microsoft. So you can deploy it to a service like Azure Container Apps, which works extremely well with those containerized native images. And they can scale to 0. And as they start up very fast, you basically can have your applications scaled down to 0 all the time and just starting up when some users arrive. And basically, you don't pay anything for this because there's a generous free tier. So you can have some very efficient and cheap applications working on Azure this way. Let's just have a look at the running application. Here it is. Of course, we deleted the database, so we need to create some new stuff. So here is our new to-do assigned to me, and everything is working with GraalVM native and my PostgreSQL database. So I hope you've enjoyed that session about building a Spring Boot and Java modern application using AI. Again, if you want to use Dr JSkill, it's available on GitHub, on my GitHub organization. If you're not happy with some decisions, well, first of all, have a look at what I did because some decisions are very carefully thought. Again, I've worked in this field typically with Jeepster for more than a decade. So I know quite well what I want and why I want it. But if you're not happy with something, just fork it and change the description. Like if you are not happy with PostgreSQL and you want MySQL, that's a perfectly valid decision. Well, just have a look at the skills.md file and modify the database to change PostgreSQL by MySQL. And the good thing is that you can even do this with AI. Like you can open up those Markdown files with Visual Studio Code, for example, and ask your AI assistant to migrate those Markdown files from PostgreSQL to MySQL. Fairly easy. And in fact, that's how I wrote most of Dr JSkill myself using AI. So it's AI, building AI. So thank you so much, and don't hesitate to put some comments so we can discuss on the future of Dr JSkill. Thank you, and goodbye.